Greetings and namaskar to each one who came here to watch this video. Topic of today's video is Introduction to Electrodynamics. Firstly, let's understand this word, electro and dynamics. Well, the first word that comes in our mind after hearing the word electro is electricity. What is electricity? It is a flow of charges. So, electro is actually charge. And dynamics deals with motion. We know the value of charge, that is Q, 1.6 into 10 raised to the power minus 19 coulomb. So basically, in electrodynamics, we study the charged bodies in motion. Additionally, we study two fields, that are electric field and the magnetic field. So, we study variation in electric and magnetic fields. Well, now we need to connect this subject with mathematics because from starting till end it is full of maths. So, initially we need to understand the concept of coordinate system. So, there are three commonly used coordinate systems, that are Cartesian coordinate, cylindrical and spherical. Cartesian is also known as rectangular coordination system. And we know that there are three axes which are mutually perpendicular to each other, that are x, y and z axis. So, it has three coordinates x, y and z. We have three coordinates rho, theta and z under cylindrical coordinates, where rho is the projection distance from the axis to the point on the surface. Let this be O and this be P. So, distance OP is the rho. Angle from the x-axis is theta and the height of the cylinder is the z. So we have three coordinates rho, theta and z, and r, theta and phi under the spherical coordinates, where r is the distance from point O to P and theta is the angle with z-axis and phi is the angle with the x-axis. Now talking about their range. So under Cartesian coordinates, we have range of the coordinates from minus infinity to plus infinity, and under cylindrical, range of rho is from minus infinity to plus infinity, and the angle theta, it can be till 360 degree, and z can be from minus infinity to plus infinity. And spherical coordinates, we have r from minus infinity to plus infinity, theta till 180 degree, and phi till 360 degree. Now, most importantly, you should know the conversion like changing Cartesian coordinate into cylindrical, cylindrical into spherical, spherical into Cartesian and so on. So let's see. So these are the formulas from which we can change cylindrical coordinates to the Cartesian, spherical to the Cartesian, Cartesian to the cylindrical, spherical to cylindrical, Cartesian to spherical and cylindrical to spherical. So pause the video here, take a screenshot so that you can use them for your numericals. So now, as you already know about unit vector, we represent it like this. R cap is equals to vector R divided by magnitude of vector R. And on graph we represent it like this. We take unit 1 and this is dx, dy and dz. We also write it as I cap, j cap and k cap. So it has magnitude 1. We will also use this. Along all these coordinate systems, unit vectors, we need to recall the vector algebra, its properties like addition, subtraction, multiplication as dot and cross product, and the vector calculus. And you should also remember the three signs, that are del, del dot and del cross. Del is the gradient, del dot is the divergence, Del cross is the curl. And you should learn the general form of the gradient, divergence and the curl. Now, coming back to the charge again. When a charge is in motion, it will produce electric field and magnetic field. And when charge is at rest, it will produce only electric field. Before that, what is electric field and magnetic field? Through this diagram, you can easily recall what is electric and magnetic field. So electric field is produced by the point charges, while the magnetic field is created in the magnets, which flows from north to south, and in case of electric field, it flows from positive to negative. So when the charge is in motion, it produces both electric and magnetic field, while it is at rest, then only electric field. So now if we want to study charge in motion, then we need Lorentz force. And if we want to study the charge at rest, then we need Coulomb force. We are already familiar with the Coulomb's force, that is F is equals to K Q1 Q2 upon R square, where R is the distance between two charges that are Q1 and Q2 and K is the constant, and force on charge in electric field is given by F equals to QE, and the Lorentz force is given by F equals to QE plus QV into B, where Q is the charge, E is the electric field, V is the velocity, and B is the magnetic field. Now, this area of electrodynamics is often known as classical electrodynamics, and it was systematically explained by the physicist James Clerk Maxwell. And we studied their equations, which are in differential form, to understand the various concepts under electrodynamics. So, these are the following four Maxwell's equations. The first equation is on Gauss law of electrostatics. The second equation is based on Gauss law of magnetism, while the third equation is based on Faraday's law, and the fourth equation is modified Ampere's circuital law. The first equation is on Gauss law, and in my next video I'll be explaining Gauss law and its differential form in detail. So now let's take second equation. Let's see what it is trying to convey. Del dot B is equals to 0, where del dot represents divergence, means something is diverging. What is diverging? B, that is magnetic field. So let's take magnet with north pole and south pole. So del dot B means divergence of the magnetic field. Del dot B. So the number of field lines that will come from N will go in S, and the same amount of lines will come back again from S and will go to N. So this means they will cancel each other, hence del dot B is equals to 0. So similarly, we will understand Maxwell's equation deeply under electrodynamics. One more thing that you need to recall again is flux. It is represented by phi. It is the quantity of electric field lines that passes through any closed surface. Means if we are having a closed surface, so the quantity of electric field lines passing through it is given by the flux. Let ds be the small area, then flux under closed surface is given by E dot ds, which is equals to E ds cos theta. So the quantity of the electric field line passing through any closed surface is given by the flux. Now few symbols like line integral, surface integral, volume integral are represented like this, or this for closed, 2 integration for surface, this is for closed surface, 3 integration lines for volume, and this integration is for closed volume integral. So that's it in today's video. Hope you found this video productive. Thanks for giving your time here. Take care.